Hello, my name is Fanola Ogunleye, and this is a presentation for cloud computing for enterprises. So, I we are going to talk about adopting cloud computing in an organization. Cloud computing is one of the hottest buzzwords in the IT world right now. The evolution of cloud computing over the past few years is potentially one of the major advances in the history of computing. However, if we adopt cloud computing in our organization, there needs to be some basic understanding, clear guidance about what it is, why use it, and the best way to utilize it. While a lot of research is currently taking place in the technology itself, there is an equally urgent need for understanding the business related issues surrounding cloud computing. We will look at a SWOT analysis of our current IT infrastructure and how it relates to cloud computing. We will also build a business case by presenting different use cases. Finally, we address some of the key issues facing organizations who, due to the unique nature of the technology, will have to become intimately involved in the regulation of cloud computing. So, what is cloud computing? According to the National Institute of Standards and Technology definition, cloud computing is a model for enabling convenient, on demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or servers provider interaction. This cloud model promotes availability and is composed of five essential characteristics, three delivery models, and four deployment models. Or more succinctly, cloud computing is a style of computing where computing resources and are easy to obtain and access, simple to use, cheap, and just work. And this includes processing power, data, applications, and storage. Well, you can think of cloud computing as a laundromat. For clean laundry, you install a washer and dryer in your apartment and pay for its upkeep, but you use it once a week. However, you want only clean clothes and not a machine that is sitting idle most of the time. Most neighbors like you also laundry once a week, but own the machine and waste a lot of money and time in maintaining them. So laundromat is a better option when there are lots of machines, and here the comparison with the cloud comes. You can go to the laundromat, stuff your clothes, and pay by the load. Similarly, in cloud, you just do the work, can increase the load as per your requirement, use more machines, and pay your load. So we need to understand the characteristics of cloud computing. Scalable. This is when a facility can allocate resources to meet business demand. Elastic. Infrastructure must be easily scale up or down automatically with no effort required by the operational personnel at time of need, and preferably minimal to no effort by the application developers in advance. Self-service. The process for adding capacity in the traditional model typically involves budgeting, acquisitions, facilities, planning, staffing, training, and more, where lead times often run into the months or even years. In contrast, a self-service capability enables the owner of an application to obtain the necessary computing resources, or at least the potential to use certain computing resources with a simple request no more than a few minutes before the need. Universal access, which includes services and more. All capabilities can be accessed from anywhere using any device or application. With the advent of the internet, anywhere, anytime, any device access went from novelty to expectation seemingly overnight. Traditional systems were typically wrapped with a web wrapper to make it accessible to either other software. One interesting byproduct of universal, self-oriented web access to all applications has been the ability for almost anyone to easily create new ad hoc applications that mix and match individual applications, data, and services from anywhere, often in very unattended ways. And finally, complete virtualization, the ability for the infrastructure components to act like one, both for the operational groups and the software developers. In other words, no matter how large a particular cloud has to scale, it remains as simple to operate and as easy to develop applications for as if it were only a single server. So these are the most common deployment models. We have a public cloud, which are computing resources that are dynamically provisioned over the internet via web applications or web service from an off-site third-party provider. Public clouds are run by third parties, and applications from different customers are likely to be mixed together on the cloud servers, storage systems, and networks. We also have the private cloud, which refers to cloud computing on private networks. Private clouds are different as in they are built for the exclusive use of one client, providing full control over data security and quality of service. Private clouds can be built and managed by a company's own IT organization or by a cloud provider. Here are the pros and cons when comparing the public versus private cloud. As you can see, with the public clouds, the pros is less expensive than the private. You can decide on short or temporary commitments, more accessible than the private clouds and easy to deploy. But on the downside, you have fewer user management control. It has a one-size-fits-all approach and is not tailor-made for the organization. And security and uptime might not meet enterprise compliance standards. On the other side, for the private, you can be assured that it's secure to meet compliance at almost every level. Single tenant environment eliminates the possibility of other companies affecting performance. Private data center usually accessible to IT auditors and customizable to meet an individual organization's needs rather than the mass approach of public clouds. On the downside, it's more expensive to deploy and maintain the public clouds. You have a longer term commitment and there's less flexibility. Now, you may be asking which route to take. Do I take private cloud or do I take the approach of the public cloud? The answer to that is why not have the best of both worlds? We introduced the hybrid cloud, which is a combination of private and public cloud with a management framework in place so that the environments appear as a single cloud, typically for the purpose of cloud peering or bursting. You can use them in cases where the capacity of a private cloud is exhausted and excess capacity needs to be provisioned elsewhere. Another benefit of using a hybrid is if you want to host most of your services in the public cloud, but opt to host the rest in the private cloud, which deals with sensitive information like credit cards, social security numbers, etc., that you want to keep in-house. Now you may be asking, what does this all mean? Should we adopt cloud computing? Should our organization consider it? What would it do for us? It seems like it's a significant change. How would it really help us? Now, we can explore the business benefits of cloud computing. We could see all the advantages in the next upcoming slides. The major driving point is it cuts costs. It reduces costs. Cloud computing offers a way to reduce IT infrastructure costs through a combination of capital expense avoidance, pay-as-you-go capacity, better utilization of virtualized commodity computing capacity, and reduce operational costs by requiring fewer internal IT resources to focus on commodity infrastructure needs. Furthermore, cloud patterns that focus on PaaS, or Platform as a Service, SaaS, which is software as a service, and using cloud operating system platforms as replacements for conventional application server and middleware needs will realize great potential for IT cost savings. Overall, the accumulated cost savings from cloud can become significant, especially for firms that avoided investing in data centers and related IT fixed costs to begin with. So this is our current data center infrastructure. We have 20 database servers, with half on Oracle SE and the other half on MySQL, 200 non-database servers, 200 terabytes of object storage, 500 terabytes of NAS storage, and 1,000 terabytes of SAN storage. We ran a simulation using AWS total cost of ownership calculator, and as you can see from the output, we were able to save over 52%, which equals out to $5 million by choosing to move our infrastructure to their platform. This does not take into account full-time employee labor and bandwidth, so we can take a deeper dive later. But as you can see, the savings are significant to even make us want to consider adopting cloud computing. Moving forward, another benefit is better asset utilization. As you can see, we're referring to better asset utilization in terms of infrastructure and people and skills. Did you know that cloud computing leverages infrastructure virtualization approaches that makes it go from the average of 5 to 15% to 50 to 65% server utilization, in some cases even higher. The same asset utilization improvement opportunity applies to storage virtualization as well. Better asset utilization reduces IT costs by reducing fixed cost overhead, maintenance costs, and IT operation staff required to run and manage a data center. In terms of people and skills, cloud computing allows you to essentially outsource your IT infrastructure, platform, middleware, and applications, depending on your cloud needs, to a third-party firm. This means you can focus your precious IT staff on more strategic and innovative enterprise requirements. This is a far better use of corporate people skills and knowledge, and offers a greater return on your people assets. You can convert fixed costs into variable costs. And related and powerful benefit from cloud computing is the ability to convert what was formerly fixed costs into variable costs, which are only paid by actual usage based on internal business demand. As you can see from this chart, majority of our capital expenses were served on hardware and the other percentages in support, but we can convert that into operating expenses, which entails subscription fees, a small percentage of hardware, and the remainder of our budget goes into savings. This is a powerful concept that's had significant financial and operations benefits for IT and business executives. So we will be renting instead of buying technology. Capital expenses, once again, are converted to operating expenses. Expedited resource allocation. Cloud computing models offers a means to quickly add operational IT infrastructure in hours or days versus weeks, months, by enabling innovation projects to bypass often slow and arduous IT acquisition and procurement processes and quickly put into production new business capabilities. This rapid time to market model will be one of the major reasons companies will quickly adopt cloud computing. Eventually, IT acquisition processes will be cloud enabled, meaning that they will provide acquisition processes and governance to explicitly support cloud computing resources acquisition models. It is also an innovation enabler. Cloud offers a way to create more innovation both within the business and within IT organization with pre-integrated IT infrastructure, cloud-enabled platforms, and business applications available in modular pay-as-you-go pricing models. Cloud invites organizations to leverage various cloud deployments on behalf of new business concepts, IT research and development, product and process innovation. We also have market response tactic. Cloud can become an integral element of an organization market response process. It could be and as an organization monitors the markets, its customers and the competitors, it can become part of the overall response framework to address emerging competitive threats, emerging customer needs, and spots markets in different geographics. It could be a procurement accelerator. It offers a way for business and IT to quickly gain access to various cloud-enabled resources like platforms, business applications, IT infrastructure, which are already installed, configured, and ready to consume simply with a credit card transaction. And finally, it could be a business experimentation enabler. The cost equation of conducting business model exploration changes dramatically when fixed IT costs and IT support costs are a much lower proportion of the overall cost for business model innovation. Regardless of the specific combinations of cloud-enabled resources you are exploiting, they become part of an overall approach to business experimentation and innovation that becomes possible via the cloud. And it has a pay-as-you-go model, which is a key feature of cloud computing, as it is on-demand utility nature whereby computing, storage capacity, or application resources are consumed only when needed, and you pay only for what you use when you use it. If you no longer need the cloud-enabled resources, the capacity is released back to the cloud pool for others to draw from. This helps align computing and storage demand with business needs, and unused capacity will not sit idle as a capital expense paid for whether it is utilized or not. And these are the three most commonly used model. Starting from the left, you have infrastructure as a service, which is a third-party provider, hosts hardware, software, server storage, and other infrastructure components on behalf of its users. We have software as a service, which is a software distribution model in which a third-party provider hosts applications and makes them available to customers over the internet. And finally, we have platform as a service, which is a service that provides a framework for developers to run their own code and so can be used for in-house application. This service is particularly useful when software as a service solutions does not meet the particular business need. We now revisit our current IT infrastructure on a more granular level. As you can see, these values are calculated annually and forecasted for the next 3 years. So our current annual charge is $1,970,000. Over the course of the next 3 years, our charge it will cost us to run our infrastructure of $5,910,000. If at the current rate of growth to support our customers, we will need to purchase more software license, which raises overall costs, plus a cumbersome task of maintaining the product with upgrade and patching. So based on this scenario, if we chose to move to a per-seat license model by adopting software as a service, or known as SaaS, we mitigate costs, and the savings are highlighted on this chart. Storage footprint has been reduced by half, and this has a cascading effect for the other highlighted fields. If we compare our current TCO, which was our total cost of ownership, with the SaaS TCO, we have an annual savings of $487,000, and a little bit, and over the course of the next 3 years, a little bit under $1.5 million, which equals to a return of investment of 129.41%, which makes accountant very, very happy. Here's another scenario. As our organization continues to grow, our data requirements will continue to grow accordingly. In order to prevent unplanned downtime involving the costly loss of customer data and potentially permanent destruction of intellectual property, it will need to have a comprehensive long-term business continuity and disaster recovery strategy. As you can see based on this chart, the cost associated with providing fully redundant systems is shown here. It will cost us, in the case of a disaster, it will cost us annually $1,070,000. Over the course of 3 years, it will cost us $3,210,000. Since the operational costs associated with creating fully redundant systems will be high, we think it will be a great idea to explore infrastructure as a service. So if we were to break it down even further, this is our current costs. Using that scenario, if we adopted infrastructure as a service solution by virtualizing our environment, we can view the side-by-side comparison that we can save money in the long run. You can save significant full-time employee workforce, reducing physical server footprint by almost 75%. Now, this includes numbers of hours required for troubleshooting cable problems, configuration issues, security holes, and so on. So these are the monetary savings that can be gained. Annually, we will save $159,583. And over a 3-year span, we will save $478,749, which equals out to a return on investment of 27.67%. Any new paradigm is not without its concerns. There are indeed objections and concerns, and which can lead to disadvantages. First, we have security and privacy challenges. Security is a hot button when it comes to adopting cloud computing, and there are some considerations. First, information security in the public cloud. Even though data can be securely kept in some sort of virtual vault, it will need to be released, processed, and used by some application which exposes publicly to attacks. The greater scale of most public clouds provides the opportunity for a higher level of expertise and security protection that might generally be provided in a private data center. Take Amazon, one of the leaders in cloud technology. Millions of customers are willing to entrust their personal details and credit cards to the e-commerce business. There should be no reason that should stop companies from entrusting AWS with their customer-sensitive data. A private cloud can be protected in the same manner as a traditional big server architecture, by a combination of perimeter access, internal controls and procedures, and so forth. This is true whether the private cloud is located within a premise controlled by the consuming enterprise or elsewhere in a facility controlled by an enterprise-oriented private cloud provider. Another concern is losing control. And you have to consider how company data is being handled. Companies will have to hand over confidential data over to a third party, and for many firms, this is a move too far. There will be worries about customer data being released into the public domain, concerns about companies being held legally responsible for breaches of privacy legislation, and worries about sensitive data being held on the server, especially when two competitors might be hosted. We should also bring attention to the location of the data. Cloud computing vendors have storage availability zones that span well into different continents. This might not sit well with companies who have business policies. For example, the U.S. Patriot Act, which compels U.S. companies to hand over personal data held on their servers if requested by U.S. authorities. As this applies to European data held on servers located in Europe, this has made some European customers rather nervous. And finally, reliability and trust. No computer network in the world doesn't have the risk of downtime at some point in its life. However, there's still the comfort blanket of being able to yell at IT department and get an up to the minute update when systems are back up. However, you are at the mercy of cloud providers and can only report the outage, but not do much else about it. Fortunately, one byproduct of cloud adoption is that the maintenance and repair of problems are also outsourced, so it may well be that any problems are resolved faster than an in-house team can act. Also, applications or services dealing with highly sensitive or confidential data will have to take privacy in consideration when deliberating on adopting the cloud. For example, the healthcare industry has to comply with privacy regulations mandated by HIPAA. Another example of the rules guarding data acts is the U.S. law known as the Sarbanes-Oxley Act, or SOX, which sets standards for all U.S. public companies, boards, and accounting firms. So you must verify if the company service provider is owned or controlled by a foreign company. Define the level of control the foreign company will have over data handled by the service provider. Another consideration is customer data cannot be compromised. The data cannot be viewed or changed by other people, including the operator. Also, the data must be protected during runtime and cannot be viewed or changed. So, some questions you should ask: what type of security measures will be used for storage, and what, if any, encryption will be used during transmission where the data is most vulnerable? Who will be able to access the information, and how unauthorized access by system administrator or staff of the cloud service provider will be prevented? So, based on the SWOT analysis, organizations can take advantage of opportunities the cloud computing provides via providing information technology solutions at minimum cost. But not all is clear. Nevertheless, cloud computing services are not free of risk. There is a risk of lack of information and system security if proper actions are not taken to safeguard data and system control. So, in conclusion, many principles of cloud computing were outlined. A pool of off-premises computing resources available for use when need, built for virtualized computing resources to maximize hardware utilization, scalable elastically up or down according to need, and controlled through the automated creation of new virtual machines, where all resource usage is built only as once. We also showed that there were significant benefits, as in converting CapEx into OpEx, which means less upfront cash as well as finer grained control over dollars spent for IT. We also showed that its agility, which is almost zero time for procurement, means faster time to working systems equals faster time to market. Security. At the time we discussed this, it showed that it was a concern, But the cloud providers specialize in security and are dedicated to maintaining state-of-the-art security, which makes them better at it than everyone else. We covered the different cloud types and deployment models, the private versus public versus hybrid, and what you should think about before deciding which route to go. We also we also discuss IaaS, SaaS, and PaaS. We provided an analysis of our current infrastructure and how we can have a better functioning IT infrastructure operating at lower cost if we adopted SaaS or PaaS. We saw some examples of that, and it can be concluded that we'll save money if we picked either one. And also paying only for what you use. What all the cloud classes have in common is a completely different economic model than purchased software or hardware. The cloud uses a pure rental model like a managed service, but it's virtual capacity, not physical. No matter what your need, you only pay for what you use. Now, this is great for businesses of all sizes. You have a zero capital startup, which is very commonplace. Is excellent for that. We might even consider medium-sized businesses who are known as heavy cloud users for corporate websites, their backups, file storage, and new product development. And for our organization, which is more of a larger enterprise, we can find the cloud to be a solution for heavy compute tasks, deadline-driven needs, and online web presence. And this concludes my presentation on why we should adopt the cloud. Once again, my name is Fanola Ngulaye, and thank you for listening.